Hello, everyone, and welcome to Jack's Math Notebook. Today, we're going to deepen our understanding of the constant of proportionality as represented by y equals k times x. And we're going to learn that the distance equation, d equals r times t, lends itself well to direct variation. But let us recap the y equals kx equation. K is equal to constant, X is the input, Y is the output, and again, K is equivalent to Y divided by X. And so now what we're going to do, we're going to replace these letters with these letters over here by saying that we're going to replace Y with D, K with R, and X with T, with the understanding that D is equal to distance, R is equal to rate, and T is equal to time. And so because we're working with rate, we know that now that R is equal to D divided by T, just like K is equal to Y divided by X. And so let us take a look at our table, which also represents our ordered pairs, in which we have 3 hours, okay, 75 miles. Traveling 4 hours, we arrive at 100 miles. 5 hours, 125 miles. 6 hours, 150 miles. And 7 hours, 175 miles. And since we're going to plug these numbers in to find out what the constant rate is or find out what the miles per hour will be, we're just going to divide the y values by the x values. And so in this case, 75, which is the distance, 3, which is the time, distance divided by time, 75 divided by 3 will give us 25. 100 divided by 4 will give us 25. 125 divided by 5 will give us 25. 150 divided by 6 will give us 25. 175 divided by 7 will give us 25 miles per hour. And this is what we're going to use as our R. And so what you'll notice here when we put this into our graph, which is a proportional graph with the origin, with the graph passing through the origin at 0, comma 0, we will notice that as we go right along the x-axis and then we move up along the y-axis, we see what is happening right here. If we travel 3 hours, we will reach our destination, which is 75 miles away. Or if we continue to go along the x-axis or to the right, right here along the x-axis to 4, we notice that we will arrive at our 100-mile milestone right here. And if we continue to do the same thing, we will see this proportional relationship in which if we travel 6 hours, we will make it to 150 miles. And if we go another hour to 7 hours, we would have traveled 175 miles. And so in this case, we see that time is independent. That's why it's along the x-axis in hours. And we see that miles are dependent because it depends on the number of hours traveled. And so with that in mind, we can say that y is equal to 25x, or we could say that d is equal to 25t. And notice that 25 is represented by k, and 25 is represented by miles per hour right here, just to let you know that the distance equation is a great application of y equals k times x. Right now, you have received a lot of information, and this would be a great time to pause the video and look things over if you like, or replay this video as many times as you need to gain a deeper understanding of the applications of y equals kx. And with that in mind, comment, share, like, and I repeat like, to Jack's Math Notebook for more content. Thank you and goodbye.